Okay, so now we want to be able to use some long division. Sometimes we cannot use one of our factoring tricks, and this is usually when we are at the point where we think it might be factored by grouping, but then factored by grouping does not work. And so we need to be able to use division on occasion. Now, when you get to the worksheet, you're going to notice there's some function notation. So I want to talk a little bit about function notation real quick and why I don't have everything as y, like y equals blah, 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 and then the next one y equals blah, blah, right? Sometimes it gets confusing if everything has the exact same name. So I'd almost want to call every equation y. Just like in this example, if I called everything Pete, it would get really kind of confusing. So, I might look at the person and say, hey, Pete, what's your last name? He says, well, my last name's Zuh. It's like, okay, so you're Pete Zuh. And of course, I can refer to Pete the dog, or Pete the rock, or Pete the imaginary friend, right? That clears things up. Otherwise, if I just say Pete, you don't know which one I'm talking about. Right, believe it or not, when I was a fourth grader, I was one of 3 students named John, and there were 4 students named Doug. Have pity on my fourth grade teacher back in the day. That was crazy. And also, if you're wondering about that crazy rock named Pete, uh, in the 70s, yeah, we had pet rocks. And $4 back then, probably like trying to spend 20 bucks today, maybe. So, like I said, with the functions, if I just call every single function y, it kind of gets a little bit confusing at times. And so if we call the first function f of x, because function starts with f, we can then alphabetically use g of x and h of x. And I'll actually come back and grab a couple of these functions in an example in just a little bit. All right, so those functions will reappear on a future slide. For long division, let's refresh our memory first with plain old numbers. So not only do we have Pete here, we've got the whole family coming into play, right? We got to have dad and mom and sister and brother and Rover. Of course, dad just reminds me that the first step is I have to divide. Mom reminds me the next step is multiply. Sister reminds me that we have to subtract. Brother reminds me it's time to bring down. Bring it down, bring it down. And then Rover, we do it all over. We repeat. And then when we can no longer repeat, Rover might remind me to look for the remainder. Okay, so if I just got some plain old numbers, I'm like, okay, divide. Does 5 divide into 4? No. Does 5 divide into 47? Yes, 9 times. So I'm going to guess 9. Multiply. 5 times 9 is 45. Subtract. 47 subtract 45 is 2. Bring down. Bring down the 1. And so Rover is repeat. So 5 divides into 21. So 5 divides into 21 4 times. 5 times 4 is 20. Subtract, and I get 1. Bring down the next number. 5 divides into 14 twice. Multiply, 5 times 2 is 10. Subtract, I get 4. Bring down, oh, there's nothing to bring down. So Rover says look for that remainder, and there's a remainder of 4. But I have to remember I was dividing by 5, so the remainder is actually 4/5. So the answer is 942 and 4/5. Now, of course, we're not dividing plain old numbers today. We're going to be working with functions. And so there are those 3 functions from that previous slide that I said was going to come back. And notice that I want to take h of x and divide it by f of x. All right? And of course, I can do this with long division. So the whole family's got to show up. Now, I'm going to focus on the 3x and the 6x to the third. I'm going to ask myself, how many times does 3x divide into 6x to the third? And it is 2x squared. If you're scratching your head on where that 2x squared came from, wait for just a second and you'll see why it has to be 2x squared. Also, I've got to think place value, so I have to place the 2x squared above the x squared. Now, the next step was that I multiply 3x times 2x squared makes the 6x to the third. 5 times 2x squared makes 10x squared. So now you see why I needed that 2x squared, because I wanted the 6x to the third to match up with a 6x to the third, right? 2 times 3 made 6. X times x squared made x to the cubed. Now, a tricky one for a lot of students is when we subtract. All right? What do you think is going to happen when we subtract? I'll get a negative 9x squared, all right? X squared subtract 10x squared gets me a negative 9x squared. Notice the 6x to the third and the 6x to the third cancel out when we subtract. That has to cancel out. If it doesn't cancel out, we got to change our guess. Bring down the next item. Divide 3x into negative 9x squared. That'll be a negative 3x. Let's multiply. I get negative 9x squared minus 15x. Again, this is tricky. I got to subtract. The negative 9x squared, subtract negative 9x squared disappears. But 3x subtract a negative 15x becomes positive 18x, right? 3 subtract negative 15. Bring down to 23. I'm like, aha, 3x divides into 18x 6 times. Again, I got to think place value when I put the 6 up there. 6 times 3x is 18x. 6 times 5 is 30. Subtract. 18x, take away 18x, of course, cancels. 23 subtract 30 is a negative 7. So the remainder will be negative 7 over 3x plus 5. All right, so there's my answer. 2x squared minus 3x plus 6 minus 7 over 3x plus 5. All right, so let's take a look at another one. And you say, okay, let's set it up for long division. You're like, wait a minute, where'd that 0x come from? Again, I gotta think place value, right? I've got x to the fourth, and then x to the third, then x to the second. I need an x to the first, and if I don't have an x to the first, I better put 0 of them in there with a placeholder. So again, I do my division, then I multiply, subtracting, and again, this is tricky. Negative 9 subtract negative 6 is a negative 3. Bring down the next term. Divide, it looks like it'll be negative 3x squared. Multiply, subtract. 4 subtract 9 is negative 5, so it'll be a negative 5x squared. Bring down the next term. Divide, it looks like I need a negative 5x. Multiply, negative 5x squared plus 15x. Subtract. 0 subtract 15 is negative 15, so there'll be a negative 15x. Bring down. Divide, it looks like I need negative 15. Let's multiply negative 15x plus 45. Subtract 47, subtract 45 is just 2. So my remainder is 2 over x minus 3. And so there's our answer. 2x to the third minus 3x squared minus 5x minus 15 plus 2 over x minus 3. If I've done this correctly, these examples are on a PDF, so you can just look at the PDF and not have to replay the video. And then if you are wanting to do this online, the worksheet is available as a PDF. You'll notice I don't put them as Word documents because Schoology does some really interesting things with the equation editor if I put it up there as a Word document. So instead, it's up there as a PDF.